let's go to the next problem. I will just solve one or two today. I will share that problem also so you can do. The question is, given an array of integers and an integer k, return the kth smallest integer present in the given array. So duplicate elements can be present and k is one index. That's all it's given. And so if the array is 1, 2, 3, 4, 5, then the answer is 3. Note that the array need not be sorted, else it will be too easy. It says 1, say 3 ones, 4 and 3 and k is 2, then the answer would be 1 because first smallest would be 1, second smallest would also be 1 and so on. So let's see how to solve it. So before going this, I want to illustrate an difference in approach if it were asked in a screening test or if it were asked in a on-site interview. So if the same problem was asked in a screening test, how would you approach it? Remember that in the screening test, what matters is that you clear the test cases. What you write in the code, whether it's a hack or whether it's too easy, doesn't really matter. So a question for you is, what would you do if you see this problem in a screening test? What would be the simplest answer and easiest one that you can cover? Yeah, I see a few answers here. So if I get this in a screening test, then the easiest way would be I will just sort the array and return it, return the kth element. So I see a few complicated answers, but as I said, like for screening, the simplest would be just to sort it and return the kth element and returning k minus 1 because k is 1. Now, of course, if this is asked in an on-site round, virtual on-site round, I would not answer this because obviously, I mean, I would answer this as a easy or brute force way, but obviously the interviewer is looking for something else, maybe a more optimized version or I mean, more nuanced version of the solution. But yeah, if it's asked in a screening test, then it's perfectly fine to just have a hacky version. Anything that it doesn't matter. So yeah, so we just pass it, and as you can see, it takes end log n because the sort itself will take end log n. Now let's see if it's asked in a onset, then this won't work. So how would we approach it? Uh, so one of the way of approaching it is, say if k is 1, okay, what would you do? K is 1 means you need a minimum element. So you will keep a array main and you will just, sorry, keep a variable main and just loop through all the numbers and compare it with main and then return the minimum answer. Now, what if k equals to 2? Say k is always equals to 2. Basically, you need to uh, return the second minimum element. How would you do that? Yeah, one answer is find the smallest element, remove it, and then find the second smallest element. But there is another solution. Instead of having one variable, I will just keep like what is the minimum and what is the second minimum element. And for each element, if it's less than min 1, then I will just keep something like this. So basically, if it is less than min1, I will just make that the minimum, and whatever was the previous minimum would be the second minimum element. Or if not, then I will compare it with the second minimum element, and if it's less than that, then I will update it. Now we can actually generalize it, keep k elements, and loop through each of these k and do it. The solution would be order of n into k, which is worse than the n log n simple solution. So that won't work, but that's still an idea. So if you see what we are doing in this k, what we're doing it is like keeping of k minimum elements is that we are just always keeping the k smallest elements right now in the whenever we are processing an ith element, we are keeping the elements that are the k smallest element till I. And whenever see a new element, we try to see whether it's one of the k smallest element. And if it is so, we will add it in the appropriate place in that set and remove one of the elements from the set of k minimum elements that we are maintaining. Now, if you see what element would be removed from k minimum. So I think it's better to talk with a concrete example. Say numbers is something like that, and k equals to 3. So after going through the first three elements, the set of minimum numbers would be something like would have only 3. Now if you see 2, we are adding 2 here. Which element would be removed from it for the set to be have the kth smallest element? Yeah, 5. And in general, what would that be? If we are adding a new element, we would be removing the maximum element from it, right? Because we want the k smallest element. So whenever we insert a new element, we should remove the maximum set. And that's the idea. Now to do it efficiently, we were doing it in order of k for each element. To do it efficiently, we need a data structure in which it's efficient to add an element and to find out what is the maximum. Which data structure would that be? Yeah, I got a few answers and they are correct. A priority queue, and to be more general, it's a heap. We can use a max heap for storing the k smallest element and always remove the. Uh, Before that, I think I got the question. Yeah. Let's just implement it quickly. Priority queue, I think, is in queue library. Now, when we are done, what would be the kth smallest element? Again, it would be the max of the whatever mean we are storing. Since the minimum would be the first minimum element, and second minimum would be the second minimum, and so the kth minimum would be the maximum of the mean set. We just did that. it's insert, it's push. It's giving wrong answer. Oh, I forgot one thing. I'm sorry. So we need to do only if the size of minimum goes above k. So basically for the first k elements, we just need to push it and not pop it. Only after the size exceeds k, we need to do it. So meanwhile, can someone tell what would be the complexity of this solution? Remember the sorting was and log n. So what would it be for this? You could argue that it is also n log n, but it's a looser bound. Can we get a tighter bound? So remember this is order n. Now we multiply it by however operations we take. Now a priority queue, sorry, a heap push takes log of number size of the heap. And since our size of the heap is always bound to k, this operation would take just log of k. Same for this one. And the overall solution would be order of n log k. Yeah. So that's how we solve this problem. Now, if you say order of n log k is a tighter bound and generally smaller because it's guaranteed that k will always be less than or equal to n. And so it's a more optimal solution than the sorting one. And if you are asked this in onset, this is probably what the solution that interviewers are looking for. Yeah, I will just see if we have some questions here. One question is for on-site round, can we use standard library sort or we have to define our own sort function? So for sort, generally, no one would ask you to implement your own end log and sort. But I have seen interviews where they ask you to implement the heap part. So if you see really in this question, there is nothing much to implement. It's just 4 lines. If you use a standard library, so they might ask you to implement your own heap instead of using standard priority queue. In general, the idea is they won't ask you to implement simple uh, functions like sort, minimum, those things, but they might ask you to implement some complicated ones just to see if you understand. So heap or definitely won't ask you to implement something like map or something. Yeah, if you just complicated, a BSTs, they definitely won't ask you to implement that, but they might ask you to implement simpler data structures like priority queues or queues. I see another question. Any reason why you didn't define namespace std in the start? Uh, there is no particular reason, especially in screening tests, it won't matter. I personally don't use even namespace std in interview or problems is because I once gave an interview and the interviewer told me that using namespace std is considered a bad practice in the industry. It doesn't matter for personal code or anything, but generally the recommended guideline for coding in professional setting is not to use using namespace anyway. Always specify the namespace before. And that's why I got it in a habit, but it shouldn't really matter. You can use using namespace. I do use it in competitive coding on personal project. Yeah, so an interesting thing is for this problem, there is also a order of an randomized expected solution. I won't go into detail, it's a bit complicated, it's a recursive solution, but it's there in the editorial. It's called quick select. It generally behaves kind of like quick sort. It's a variation of, it uses the same technique as that. You should definitely read it. Another question is, can we use hash include bit slash std h in interviews? Bit slash, for those who don't know, bit slash std_c++.h is a header which uh, in turn includes all the headers that are there. I would discourage against using it because first of all, it's non-standard. It is not guaranteed to compile in non-GCC compiler, and also I mean, it can be construed as a signal for being lazy. I mean, a better idea would be to just include the library directly if you can. And again, for screening test, all this doesn't matter. Use hash include bit slash std and using namespace std. Nobody would be looking at the code for screening test. In fact, I would recommend you use this in screening test because that would cut down your time. You don't have to spend time thinking about which library to include. Yeah, so I guess next question is island sizes. Again, before solving the question, I would like again ask, are there any other questions related to the ways how to prepare? I will give this link to. So we are given a 2D grid of ones and zeros, where one represent land and zero represent water, and we have to give the size of each. So an island is said to be a connected set of land, a series of connected cells, and the cell is connected if they share an edge or a corner. So for each cell there will be eight neighbors, diagonal and orthogonal both. We have to find the size of all island in the map and return them in sorted. So another variation of this question that you might be asked is island count, where you just have to count the number of island that you have to return. Uh, and I should say that this question is the most frequently asked question in interviews. I mean, across all companies and everything. So that's why it's here in the getting started list. Uh, I mean, they probably won't be asked for freshers because it's considered a bit easy and it's common, but still it's one of the most easiest one, and there might be some variant or it might be a starter question. So I will just go through it anyway. So I mean, how would you approach it? What is the technique for this? Yeah, so the technique for this would be to treat this as a graph vector, such that each land cell represents a node, and whenever they are adjacent, there is an edge between them, and you have to return the size of each component in the graph. A component is just a connected set of nodes. So, so now, how would we find the size? It's to graph traversal. What is a graph traversal? It's just a technique for traversing graph. There are maybe two techniques. One is BFS, breadth first search, and DFS, which is depth first search. Either would work here, but DFS, depth first search, is a bit easy to implement here because it's recursive and has a shorter line. So I will demonstrate it here. How DFS works is, uh, I guess instead of saying and then implementing, I'll just explain as we go. How DFS would work is it takes a node. So here node represents a cell, and each cell can be uh, represented by a row and a column. So that's what I will do. Now, what happens in a DFS is for each node, you mark that node as visited, and you visit recursively call the DFS for each of its neighbor, which would in turn recursively call for their neighbor, and so on. If you Why we mark visited is because we want to make sure that the same node is not repeated twice. Because if in a recursive call you have a same node coming again, then it would again come here and so on and go to the stack also. The aim of DFS is to discover all the nodes. So we don't want to process one node more than once. That's why we keep visited. So let's just keep one. In general, it's also useful to have the size of the grid. So that's what I will do. N is the number of rows and M is the number of columns. So what DFS will do is if you call it on a particular node, it will process all the nodes connected directly or indirectly to that node. So let's see how it happens. First, we mark as visited, like this. Then we loop through its neighbor and recursively visit it again. How would we do it here? Is that since we have a cell and we need to visit all the 8 neighbors, instead of manually encoding all this, we can. There's a technique where we encode everything in two arrays. One which says what should be the diff in row, and the other which says what should be the diff in uh, column, and just look through it. So, for example, if we want to for all rows above the current row, it would be something like this. And in the same row itself, there are 2 neighbors, and in the row below, there are 3 neighbors. Now, for each of these, we specify the corresponding column to the left, same column, or column to the right. So this specifies all the neighbor for I. So for I comma j, all the neighbors can be gotten by looking through this and taking I plus bi and j plus bj. So that's what I will do. I'll say neighbor of I equals to I plus bi of b. Same for j. Now we have to make sure, say the cell is at an edge or at a corner, then say it's 0 comma 0, then we will first go to -1 comma -1 when we add the first two tips. That would take us outside of the grid. To avoid that, we need to make sure that it's inside the grid. So that's what we will check next. And we also need to make sure that it doesn't go above the 0th row or below the n-1th row. That's what we're checking. we have to make sure the bounds for I are between 0 and n minus 1, and for j it's between 0 and n minus 1. That's what we're doing. If it is within the bound, we just recursively visit that neighbor. Now, we are still not done a couple of things. One is that we have to make sure that we are not visiting the same node again. So let's do that. If we have already visited a node, we will just return instead of recursively resolving on its neighbor. We could also add it here. We can make sure that, in fact, let's add it here. That will make more sense. We will only visit a neighbor if it is not already visited. And one more important condition would be, remember we have land and water, 1 and 0. So we need to make sure that the neighbor that we are visiting is also a land. So that's what we will do. Only if the neighboring cell is a land and we are not already visited it. Now for that we will need a grid also. We can just create a copy. Okay, now how to call this? Remember that if we call for a cell, all the connector component would be visited. So we need to call it from each land, but we need to make sure that we are not calling from a cell which we have already processed. So how would we do that? Just first look through each row and each column and make sure that it's a land. Just do this. We can make sure that we are not already processed it by checking visited. Now we'll just call DFS with those two values. So this would ensure we are processing each island once. Now let's get to the actual question. The question is asking for size of each island. So to calculate that, let's keep a global variable which we would clear every time. Every time we are calling a new DFS, we will clear it. And DFS would just, in DFS, we just need to calculate how many times a DFS is called. This function is called recursively because it's only called once for each cell in the island because of the visited check that we did. So we just implement it. Once we get the island size, we need to add it. So for that, let's keep another vector. Finally, it's asking for a sorted array. So let's just sort it. And we also need to include the header for sorting. And that's where it should work. Let's see. I would encourage you to try this problem also. Don't just like rely on watching it to learn it. make sure that you implement it. If not now, then after the session is ended. Okay, saying we are getting wrong answer. Let's remove it. Luckily, it's for sample itself. Let's see what is the case. Since we are getting runtime, we are probably accessing some, I mean, some either wrong grid or going into Stack Overflow. Let's just make sure we are not doing that. Uh, Here we should be checking for a neighboring grid, not for the current grid. Let's see if that alone was the issue. It's a runtime again. Let's just start printing stuff. So whenever you are facing like a debugging problem, especially the screening test, most of the judges that are used for screening problem have this feature of returning the logs. Whatever you are printing to STD out and STD, they would return, especially for samples. So make sure you use it if you are stuck. Also, if you find anything wrong in this, let me know. At this point, I will just more logs will get interested. We are looking through the grid here and not visited already. Oh, yeah. We have not initialized the visited array. So let's just initialize it. It would have row and a column, each of them initialized to false. Yep, that works. Now we can review the pivot statements and so on. Yeah, meanwhile, and there are some questions, so I will just answer. One question is, can you give some tips about projects to get on your resume? As in, should we keep a variety or focus on a particular technology? In general, I would recommend you pick one or two technologies and stick to it. But the thing most interviewer is looking for are not the actual technology that you're working on or even the actual project. It's how you present it and how you communicate about it. That's what interviewers are looking for. So I would say at the end, it doesn't really matter. Could have from different technologies, or if you're aiming for a particular role, ML, AI, if you have a lot of projects in that technology, it entirely depends on you. The important thing is that you are prepared on it and sound confident when talking about it. So before going to the next question, it's getting a runtime. There's actually a bug in this code. Not really a bug, there is an assumption. Can one of you spot it? We are assuming something in this function that might not be true. It's specifically in this line. I'm getting some answer. It's that the dimension of the grid, we are assuming it to be not empty. Now, most of the judges, or depending on the company, they might exclude this input altogether. They will say that we will have at least one row, at least one column. But it's not a guarantee if you don't see that in the question. So in this question, there is nothing given about the constraints. So you should not assume that it will always be non-empty. So always keep that in mind. To solve this, we can just have, since n is zero, we can always return just an empty array that is submitted. Meanwhile, I will go to the next question. How does the interviewer judge if your resume project has value? Uh, Again, unless you are applying to a very specialist role, an embedded system role, or I don't know, AI ML role, uh, most interviewers are not looking for whether your project itself has value. And of course, if it has value, if it is unique, then good for you. But even if it doesn't mean that it has no value. What we are looking for more is what as an interviewer is looking for is how we are able to answer questions about it, how confident you sound, and I will be looking for signals like whether you have really worked on that project and how deep have you thought about it. I might ask questions about why you have the approach you have taken in that project, why you did not use another approach, or maybe I will ask what was the biggest issue that you had and how did you solve it when doing that project, anything like that. It's more to get uh, signals on how you are approaching that rather than the project itself. Now, this doesn't apply if you're applying for a specialist role, but yeah, other than that, in general software interview, we are more looking for how you reply to these questions, not the project itself. Another question is the session recorded? Uh, I know yesterday's session was recorded. I'm not sure about today's session. I will maybe ask the organizers to share the link. Yeah, that's it. We already solved two questions. if I don't know if you want me to solve one more question, or if you have like in general any other queries or something else you want to ask about how to prepare for particular topic, then I will be happy to answer. And again, a reminder about this drill that you have created. If you are just starting out in algorithms or are not really fully feel confident in look through the problems, it contains about 10 of the frequently asked and covering a wide range of topics. You can use that as a starting point. Each of the problem will have editorials. So, and there are other drills also you can explore if you are preparing for a particular company. It's also there for a particular topic. So if you guys have any questions about any topic, how to prepare for DP or graph or something, I can talk about that. Yeah, I'm getting a few questions. What all categories should we focus on? So for that, we have a list of topics. So some of the topics that are generally asked are ad hoc. So the topics generally asked in interview questions are here. Ad hoc questions, which have some tricky ones like the famous egg problem or trapping rainwater or Conway's game of life, which are like require some specific knowledge and they don't really have any generalizable stuff. So the best way to prepare for them would be just to make sure that you have solved all the problems and know the solution for them. Yeah. So for example, maximum subarism has a very specific solution which is not easily generalizable. So it's best to just look for it and learn the solution and remember. Ad hoc problems are usually like that. Either they are very straightforward, like physics, or they require some specific trick question kind of thing, like trapping rainwater. In fact, I think I can spend the rest of the time going through each topic and just giving some tips how to prepare for it. I'm getting questions on each of the categories. So that's for ad hoc. Sorry. Next would be array problems. So mostly it's about say, looking through an array like two sum, three sum, or find the kth smallest elements. These are also generally have their own solution, but remember to make sure that you know the variance of it. So even something simple, right, like find kth smallest, but maybe you could get find kth largest. You should be able to adapt your kth smallest element to find the kth largest. Or maybe you will have find kth smallest distinct element instead of considering duplicates separately. You should be able to handle those two. So make sure that when you solve any problem of this type, you remember to think about the variance and how to solve this. And two sum is also a very common question that is asked, and they have interesting solutions and extensions of it. So make sure you solve this. Next would be binary search problems. So in binary search, the trick is to make sure that so when binary search can be applied is when the function is monotonic and you want to find either the smallest or the largest. So make sure that you understand the patterns of it. There are only two, three patterns in binary search. I mean the solution pattern, and you can just learn all of them. And one thing is make sure that there are cases where if you implement improperly, they might be off by one errors, and your binary search loop goes into infinitely. So you have to make sure that you got it covered. Always make sure if it's an edge where, like, say, generally the type of question asked in interviews don't really have a continuous function. Rather, they have Boolean functions where you have to find either the first indexes which returns true or first indexes which return false, something like that. Uh, so to do that, make sure that if high and low, which are the two variables, low and high, which are the two variables that signify the range, if they are near each other, say low equals to 3 and high equals to 4, and one of them is the answer, then make sure that it happens. Because if we have a off by one error, then low and high would stay the same even after we do, and it will have an infinite loop. So in binary search, I usually found it helpful to think about the case where both low and high have are near each other, adjacent to each other, and how the loop is also. Next question is, next topic is brute force. Brute force generally doesn't isn't really asked as in no problem would itself have a brute force solution unless it's a very heavy implementation problem or a simple warm-up question, like find the longest palindromic substring. Even that might have specific algorithms, but brute force might also be acceptable. You need to, I mean, brute force is just going through all these possible solutions. So pretty much any problem will have that solution. So make sure that, as I said in one of the slides, brute force is probably one of the first solution that you will come up with when you see a problem. Make sure that whenever you see a brute force problem, you analyze its complexity correctly. So in some cases, like longest palindromic substring, maybe that complexity is enough to for you to solve the problem. So make sure you understand that. Brute force, apart from brute force, always make sure whenever you are writing or thinking about a solution, you calculate its time complexity, memory complexity, and see if it fits within it. The next would be DFS problem, like the one that we saw. That should also be here. But yeah. DFS is generally just a graph and a recursion. So uh, if you solve a few problems, you will easily get a hang of it. You just need to keep track of things like visited array and how to call the DFS function initially. All those things are something to keep in mind, and how to compute the neighbors efficiently of each node. Once you figure out all those, DFS should be pretty straightforward. Now DP. So DP, or dynamic programming. How to prepare for this is for first, remember that dynamic program, how I view it is, it's just an extension of recursion. If you can figure out how to solve a problem recursively, and that recursion the arguments that you pass to that recursive function repeats, then you have a DP. So DP is not that big a deal. You just the important thing that you need to focus to solve DP problem is actually recursion. You need to know recursion very well, how to think about a problem recursively, how to keep track of the state and go through. So technically, how I will just talk a bit more about DP because it's the most commonly asked question to me, how to prepare for DP. Think about the structure of DP as the state. The state is the variable that you pass in the recursive function. And second is the edge cases. What happens when the state is straightforward? How do you return the answer? And the third is transition. How you transition from one state to the next state, and how you recombine these results of the transition state back to the original one. So that's all you need to remember generally in DP. And whenever you study a solution, make sure you break it down into these components so that you can reuse some of these components and techniques in other solutions. And the best way to study DP would be to study the, sorry, study the common standard solutions like coin change, edit distance, all those are very standard solutions. Once you do that, you will come to know it. Generally, in interviews, don't really look for iterative DP. they are fine with recursive ones where you add conversation. The reason is iterative DP is quite hard to implement in one go. So most interviews don't really ask for it. And again, like just make sure that you're practicing at least the standard DPs. And there are graph problem. I think we solved one graph problem today and one yesterday on topological sort also. Yesterday, I had given a list of topics which were commonly asked graph problems like topology. First, there is DFS, and jigsaws. Then there is topological sort and uh, connector components, strongly connector components, minimum spanning trees, all this thing. So the best way to approach graph would be to learn these algorithms first and maybe solve one simple problem on how directly to build these algos are applied directly, and then practice more graph problems from it. So that's the way I would approach it. Make sure you learn all of the commonly used techniques in graph. Next should be hash map related problems. Those are generally straightforward. Hash map is just a way where you don't know the bounds of the input beforehand and you just want a key to value pair in average constant time. So whenever you are using hash map, make sure that you are saying that it's on average it's a constant because each call can take like each call. It's not guaranteed that each call to a hash map would take a constant amount of time. It's only on average to give it. In fact, it is possible to construct, if you know the hash function, it is possible to construct malicious input where you can actually have a timeout because of the amount of, uh, the amount of time it takes for each of the hash functions. And there is some Mathi problems where maths is basically used. Mostly these are straightforward. No, I have never seen like a number theory problem in interviews. It might happen generally as to competitive coders, but yeah, otherwise the maths part is straightforward. Just basic like base or how to convert bases or how to break a number into its digits and all those easier things in general. Make sure you have practiced those. And there is queue related problem. Generally, sliding window and queue related problems are closely related. Uh, yeah, so I don't really have much to say about queue. Just make sure whichever language you are using, you know how to use the queue, which imports you need to add, and what are the standard methods for queues. And of course, queue is also used in standard algos like DFS. Next, we have recursion. So recursion is probably the most important technique. If you want to start with one of the topics, I would strongly recommend recursion because once you have mastered recursion, you have automatically like mastered. You have a long, halfway to mastering DP and almost mastered DFS. Everything is recursion. So make sure you understand recursion thoroughly and very solve. Maybe I would recommend at least solve all these 6 programs which are present here using recursion. That would go a long way in practicing for it. And I guess sliding window also it's like uh, pretty much application of something within a sliding window. It generally has length of distinct characters and all those. Again, I feel that many of the sliding window problem, while they have something in common with each other, it's the actual thing inside the sliding window. In sliding window, basically you maintain two pointers and move either the right or the left depending on some conditions. That conditions are pretty much ad hoc, but the technique of moving the sliding window is common. So once you solve one or two, you should, it should be easy to solve the other. Not easy, but the technique itself would be learned. And you just need to focus on what is inside that sliding window. Sorting is just, I guess, a general technique. There's nothing specific to it, but I would strongly recommend that you learn how to use sorting in the language of your choice, how to say modify the comparator function, and how to use pairs and whatever is the equivalent in the language that you use. Make sure you do all this. And I would say similar, same for stack. Uh, I mean, stack is also a very similar to queue, whatever the advice I gave for the place to stack also. And then we have string problems. Generally, string problems are like have like palindrome or anagram, something like that, or parentheses. So there are two, three common things. Once you master all these things, it should be fine. Yeah, once you master all these things, you would be. I mean, you should be able to handle most of these string problems. Something like string matching KMP, I don't usually see in interviews. It might be asked in rare cases, but even if it's asked, it will be considered a hard problem. So before going through any advanced string specific algorithm, I would strongly recommend you learn basic stuff like palindromes and anagrams and parentheses. And then we have try. Uh, a couple of problems of try are possible and are asked. But if you are like ordering by topics, I would put try at maybe most very last one because it's quite rare, but it's still asked. So once you have finished up the other topic, this might be a good thing to do. And yeah, two pointers is also very similar to the advice that I gave for sliding window. You just need to, if you solve one or two problems, you will know the basic technique, and then the trick lies in what to do inside the technique. It's like binary search or sliding window. The overall structure is the same for each problem. You just need to figure out the details. So once you solve one or two problems, you will know the structure. Then for the details, the other techniques are useful. So that's about all for each topic. And again, the overall advice always applies practice a lot. These provide you a starting point. Make sure at least you have solved like 50, 60 problems by the time you have, I mean, and all those 50, 60 problems should cover each of these topics. I know it's daunting, it's a lot. The best way is to practice regularly, like have a aim of one or two problems each day. And I've found it's always best to practice in a group or with a friend so that you can easily discuss it. Often ways when you learn or when you are teaching your friend or when you are listening from your friend, it gives you a different perspective and it's easier to learn and understand. I know it's hard because now we are in virtual, but yeah, it's still, I mean, I would still strongly recommend it. So yeah, that's all for each topic. Another question I have is, please feel free to ask any questions. I mean, I don't have any material from my side. If you have any questions, do feel free to ask. Uh, I have a question. What about capture the flag? Is it useful for an STD? So, what is capture the flag? I'm not sure. Okay. Okay, it's yeah, yeah. It might be useful. I mean, it's definitely. I won't say it's not useful. Even for every job, it might be considered. It's, I would put it like the same level as something like GSOC or competitive programming. If you regularly participate in capture the flag contest, yeah, you should definitely mention it and be used. Yeah, let me know if you have any more question. And that's it for the content from my side. And also remember, we have a Facebook group. I will ask the organizers to share the links of these problems. I will also share the slides soon, especially for the MCQs when they release each of the important topics. And if you have any questions, how to prepare or anything for particular question, how to solve this problem, I didn't understand this solution, then please feel free to ask in the group also. I will be checking the group frequently and I will answer them. One question I got is segment tree an important topic? I would say important topic. I mean, the question to ask student is it important? I would say rather, is it a frequent topic? If it is frequent, then it would be important, otherwise not. And yeah, no, it's not a frequently asked question, generally segmented. But I would say it's more frequent than tries. So, but less frequent than most of the topics listed on the screen. So, yeah, I would put somewhere along that. Another question I got is how to enhance speed for tests. Yeah, the only way to enhance is practice a lot. Like each of the remember that you have to solve a problem in just 20 minutes, like we had calculated earlier. So reaching that level is not easy. It requires a lot of hard work and a lot of practice. So make sure you start as soon as possible. Make a plan today. Maybe start solving some of the getting started problems, but make sure you practice a lot, and that's the only way you can improve the speed. I think I'm seeing no further questions, so I'll just wait for a few seconds. If no further questions, we can wrap the session. Okay, I don't see any questions. So yeah, thanks all for attending the session. I hope you found it useful and all the best for your placements.
Yeah. Thank you, Balaji sir, so much for such amazing insights. Uh, we hope all of you had a great learning opportunity, and we will be posting all the material we have with us on the Facebook group. Also, feel free to ask any questions you have on the group itself. Yeah. Thank you so much.
Thank you. Bye.
Bye.